A very good evening to you all, and welcome to today's session. Today, we'll be looking at Module 15 and Module 16 of our CCNA Network Training course. Hopefully, by Saturday, we should be rounding up the training for the lecture sessions. Then you will have 1 week to be able to complete all your assessments, which means that once we are done on Saturday, then you have from Sunday down to Friday or Saturday to complete your assessment before we begin the graduation process for CCNA1. And then we will know when to commence CCNA2 session. So I want to thank you for your patience and your continuous support for this program. So Module 15 is application layer. As you are aware, we have been looking at the different OSI model layers, and we're looking at peculiarity in each of those layers. And in the last class, we were able to look at the transport layer. So after the transport layer, we have what we call the application layer. Okay. We have what we call the application layers. Now, in the application layers, it covers the presentation layer, the session layer, and the main application layer itself. So that's what we're going to be looking at, okay? Now, in this particular topic, we'll also be looking at the peer-to-peer, the web and email protocols. We'll be looking at IP addressing services and so on and so forth. These are just but applications that are connected to the application layer. So the upper three layers of the OSI model, which is the session layer, presentation layer, and application layer, tallies with the TCP IP model of the application layer. All right. So as you can see that the TCP IP model, the application layer tallies with the session, presentation, and application layer. So they're usually called the upper layers. So the application layer actually provides the actual interface between the applications that are used to communicate and the underlying network over which the messages are usually being transmitted. So where you build your services like your domain name or your DNS or your web services or HTTP or your SMTP, your mail service, your POP, post office protocol, or your DHCP, all right? All of these services are services that you generate on the application layer, okay? And since you generate these services on the application layer, it helps the system to be able to know how best to communicate. So your ability to understand the functions of each of these services will really greatly help your own understanding of the application layer. That is under services. Now, the presentation layer has three primary functions, okay? Because we'll look at the presentation and session layer also. So the presentation layer has three primary functions, right? One is formatting or presenting the data at source. Then secondly, compressing that data or decompressing it. Then thirdly, encrypting the data, okay? So formatting of data, compression and decryption, and encryption as of the data. And when you are formatting it, you use different formats depending on the type of data. For instance, you can use MKV for video files. You can use MPEG. You can use MOV. You can use GIF for pictures. You can use JPEG. You can use PNG. All of them are different formats, and they are being managed by the presentation layer. The session layer on the other side creates and maintains dialogue between the source and the destination. So from the time that your transmitter is trying to talk to the receiver, or the sending device is trying to talk to the receiving device, there is a door that is open to enhance communication between the two of you. And that door is managed by the session layer. So once the communication is open, the door is open, you are free to begin to talk and communicate or send your data. But the moment that the conversation is over, then the door is closed. So that is managed by the session layer. So it handles the exchange of this information, to initiate dialogue, keep them active, to restart the session when disrupted and things like that. Okay. The TCP/IP application protocol specify the format and control information necessary for many common internet communication functions. So the application layer protocols are used by both the source and destination device during communication session. So for communication to be successful, the application layer protocols are, that are implemented on the source and destination host have to be compatible. All right. For instance, you have the DNS. If you are using DNS, DNS functions on port 53, and it translates the domain name to the corresponding IP address. DHCP, on the other side, functions on port 68 and 67, and it dynamically assigns IP addresses to end devices. Then you have the web protocols. The HTTP functions on port 80 or 8080, and it's just a set of rules that exchange text, graphics, images, and things like that. Okay, so when you talk about peer-to-peer, you are talking about where you have both devices serve as client and server. A client is a system or a device that requests for services from a server. A server, on the other side, is a dedicated computer that provides special services to clients. Okay, so in the client-server model, the device requesting for information is called a client, and the device responding to the request is called a server. So application layer protocols describes the format of the request and responses between the clients and the server. So in a peer-to-peer network, two or more computers are connected via a network and can share resources, without having a dedicated machine called a server per se, where the application is run. So every connected device in each case can both serve as a client or server. For instance, you see this system 2 is connected directly to a printer, and you can set up this system as a print server, okay? While this guy can be set up as a file server. Now, if you are having peer-to-peer connection between these two, this peer 1, this system can serve as a file server to this guy, and this guy can serve as a print server to this guy. So that is how they work, okay? So the common P2P applications that are often used are like BitTorrent, Direct Connect, eDonkey, Freenet. So for those of you that are that intend to go for cybersecurity, these are very key elements that you need to know. For instance, you wish to block some of these tools, you need to know the protocols or the port numbers in which they run. Remember, we had said at the beginning of this training that by the time you are done, once you are going for your cybersecurity training, any topic that has been covered by the CCNA1 training class may not be covered at the cybersecurity class. Okay. So when hypertext transfer protocol is one of the applications or services that are set up at the server at the server, all right, that enhance communication using a web protocol. Okay, so you want to browse, for instance, you want to reach a particular web page server, so you use hypertext transfer protocol or HTML, hypertext markup language, all right? So how it does is that you have a machine that hosts the particular HTML files. So somebody wants to access it. It's like you are browsing. You just type the domain name and then it brings up the HTML to the client server. So that's how it works there. Okay. Now, email is a store and forward method of sending, storing, and receiving electronic mail. Email messages are stored in database on mail servers. Email clients communicate with mail servers to send these emails as well. So if this guy is sending email and this is the recipient, the mail is actually going to go and sit on a particular server, and that's the mail server. And then this recipient is going to now receive the mail because the communication of the mail is happening just between these two servers. That is just it. That is where the communication of the mail is happening. So you see ISP A, mail server A, this is mail server B. So let's say this is Gmail, this is maybe Yahoo, all right? So if I am sending email, I am in Gmail, I'm going to Yahoo. All that happens is that I will access this server and then send the mail here. But the users are going to be receiving the mails. They need to download it to their PC. For them to be able to do that, that is where they need this post office protocol or they need a IMAP. All right. These are different mail protocols that helps you to download your mails. All right. So when a client sends email, the client SMTP process connects to the server, and the SMTP process excuse me. So the SMTP process is known for port 25. That's where mails run through. So after the connection is made, the client attempts to send the mail to the server across the connection. Okay, so when the receiver receives the message, it either places the message in a local account. If the recipient is a local or a user, you now access it. But if not, the mail is now forwarded to the next particular server. So mails basically work based on servers. So it moves from one server to the other, and then you need this POP, Post Office Protocol, or IMAP to be able to download it to your system. IP addressing services is another service offered by the application layer. And in the IP addressing services, you have the domain name services and the DHCP. The domain name is just a service that helps to translate domain name to their corresponding IP address. Now, every machine on the network has an IP address. And that IP address is what is uniquely identifying that machine on the network. So the domain name is just responsible for converting the name to the IP address. So for instance, if I type cisco.com, it is now going to translate it to the IP address of the server that is hosting cisco.com. All right. So DNS is the guy that helps to do this particular translation. Okay. So in fact, let me see if I can share my command line. See. Okay. So where is it? Where is it? Okay. So now you see if I now ping google.com, this is a domain name, all right? And it is a domain name google.com. The moment I press enter, I am going to get a reply from the IP address. Okay. So let me say ping google.com. So you see, I'm getting a reply from the IP address. So if I go to my browser, I just copy this IP address and I drop in my browser, it's going to bring for me google.com. Let us give it a try. Let me copy it like this. Okay, let me share my Windows, my listing. Okay, so this is my browser. I guess you can see. So if I put the IP address, this is the IP address. If I press enter, I am expected to see Google. Okay, so it's going to take me to Google. Can you see? It's bringing me to Google. And it has changed the name from the IP address to the domain name. Why is it so? Because the IP address is that IP address is the IP address of the Google server. Okay, so the DNS helps to do this translation and stuff like that. Okay, now the DNS server stores different types of resource records that are used to resolve these particular names. Okay, because how does the DNS know which IP address is for which domain? Okay, there are certain records that it uses. So we have what we call the A record. The A record, okay, is what we call an end device IP address record, which means that it's going to now contain the IP address of the machine itself. That's the server itself. So the A record contains the domain name, the IP address of that particular machine. Then what we call the NS record, the NS stands for name server. Okay, it stands for name server, and it's usually an authoritative name server. Name server is like the machine that carries the name that you are talking about, because you see, you are trying to manage or how do I put it? You are trying to merge the IP address with the corresponding domain name. So the name server talks about the domain name, all right? Then you have the quad A, all right, or the quadruple A, usually an end device IP version 6 address. So you see, this one is just an end device IP version 4 address. This one is the one for IP version 6. Then the MX, which is for mail exchange, is basically for emails. So this is the one that carries email records. So DNS carries or works with these types of records: the A record, the NS record, the quad A record, and then the MX record. So when a client makes a query, the DNS server process first looks at its own record to resolve the name. If it is unable to resolve that name by using the stored record, it contacts the other servers in order to help him resolve that particular name. So after a match is found and returned to the original requesting server, the server temporarily stores the numbered address in the event that the same name is being requested again. All right. And that's why whenever you are putting your IP address details, you need to also put a DNS server or DNS IP address. All right. So there's what they call the DNS hierarchy, and the DNS hierarchy is helping us to be able to understand how the domain name works. Okay, so there's what they call the root level domain name. The root level domain name. And in the root level domain name, you will see something like .co, .au, .com, .edu, .net, and things like that. These are mostly root level domain names. Then you have what we call the subdomain name. All right. That is a domain name inside the root level domain name. And we call them the second level domain name. And in the second level domain name, assuming your primary domain name is .com, all right, let's say mbte.com, then you can have a subdomain name like, let's say second level, let's say cisco.com. Then under the cisco.com, which is the root level domain name, then you can have mail.cisco.com. You can have ftp.cisco.com. You can have things like that. Okay, so that's how you get to know the subdomain name. So let's say you have mbte, you can have maybe students.mbte, or you can have transcript.mbte, or you can have the name of the institution.mbte and things like that. Okay, so the ns lookup command, usually in an operating system, it's a utility that helps the user to query the DNS records that have been configured. For instance, now, if I just type, where is it? No, not here. Okay. So if I now do clear screen and I do ns lookup, okay, it's going to now run a small query on my own DNS, the local DNS that I have on my machine. Okay, so while it is running that, it says that the utility can be used to troubleshoot and resolve domain name issues. So when the ns lookup command is issued, the default DNS server configured for your local host is displayed. And what is our DNS server? This is our DNS server. How do I know it's our DNS server? If I come here, I see ipconfig /all. It's going to give me, can you see, this is my DHCP. Where's my DNS? Where's my DNS? Okay, see my DNS. So you see, DNS server, this is it. So when you type the ns lookup, it helps you to bring out that. Another service is the DHCP, Dynamic Host Control Protocol. And the main job of this DHCP is just to issue out IP addresses dynamically to your systems. Because it's believed that every device that needs to connect to the network needs an IP. So it's either you assign the IP statically or you assign it dynamically. So whichever one you decided to do is good. But for DHCP, it helps you to assign it dynamically. So when DHCP is considered, it is often used in large scale or where you have a lot of systems that need connectivity. All right. So many networks use both DHCP and static. You use static in most cases where you have DMZ, or you have your servers, or maybe you want to assign IP addresses to your routers and edge devices and things like that. Then you can use static. Then, but for your laptops, your mobile phones, your normal other user devices, you can use a DHCP. So how does the DHCP works? You know, first of all, a message is sent, a DHCP discover is sent when a client comes on the network. Okay, once a client comes on the network, it sends a DHCP discover message in order to is looking for, trying to discover any available DHCP server on the network. And if he finds one, then that DHCP server will now send a DHCP offer. Okay, it will send an offer, and that offer is like a list of IP details to the particular client, all right, to tell the particular client that, look, I am a DHCP server. I have available IPs to lease out to you, but you need to make your own request. Then the client will now go ahead and place his own request, all right? So the client sends a DHCP request message that identifies the explicit server and the lease offer that the client is accepting, all right? So if that's the case, then the server now sends or returns with a DHCP acknowledgement to acknowledge that, yes, that particular IP address is now leased to you for the period that is being specified. Another service is the file sharing service. And in the file sharing service, it just helps us to share files from one end to the other. So that's all about module 15. So let's quickly enter module 16. And it's talking about network security fundamentals, all right? So let's look at security threats and vulnerability. Based on this, we have different types of threats. So attack on a network can be devastating and can result in a loss of time and money due to damage or theft of important information or assets. Intruders can gain access to the network through software vulnerabilities, hardware attacks, or through guessing someone's username and passwords. So intruders who gain access by modifying software or exploiting software vulnerabilities are called threat actors. They're called threat actors. Okay. So after the threat actor gains access to the network, there are 4 types of threats that may arise. One is what they call the information theft. Second is the data loss and manipulation. Third is the identity theft. And then fourth is the disruption of the service. Now, vulnerability is the degree of weakness of a network or a device, all right? So some vulnerability is inherent in routers and switches, desktops and servers, and so on and so forth. Well, we call them factory default, defect or something like that. So there may be a vulnerability in the hardware or vulnerability in the software or vulnerability in whatever it is, but there are different vulnerabilities. So there are 3 primary vulnerabilities or weaknesses. One is the technological vulnerability, which might include like the TCP protocol weakness or the operating system weakness or the network equipment weakness. All right. So those are the technological vulnerability. The second vulnerability is the configuration vulnerability. And that basically includes unsecured user accounts or system accounts with easily guessed password, or sometimes misconfigured internet services, or unsecured default settings, and things like that. But this second vulnerability is attributed to the administrator, the network administrator, the person that manages the network, the person that sets up the network. So this one, the first one, technological vulnerability is mostly added to manufacturers or developers. This one, second one is to network administrators. Then the third one is like organizational leakages. So we call it security policy vulnerabilities, which may include lack of written security policies, or authentication continuity. So administration, we could just call it administration. Physical security. If network resources can be physically compromised, a threat actor can deny the use of network resources. So the 4 classes of physical threats are hardware threats, environmental threats, electrical threats, and maintenance threats. So let's look at network attack. We have different types of network attack where we talk about malware. Malware is just malicious ware. Okay, so it's a short form for malicious ware. It is a code or software specifically designed to damage, destroy, steal, inflict bad or illegitimate actions on data, host, or even network, right? So we have different types of malware, right? We have different types of malwares. Um, right? So they include like viruses, and a virus is like a computer software or malware that propagates by inserting a copy of itself into and becoming part of another program. And interestingly, it also spreads from one computer to the other, maybe using flash drives or emails or whatever it is that is used to convey the virus. Then we have another malware called the worm. The worm are similar to virus in that they replicate functional copies of themselves and can use the same type of damage settings. So it contrasts to virus, which requires spreading of infected host file as standalone softwares and do not require a host program or human to propagate it. It usually propagates itself on a network. Once it senses that you're on a network, it can move across the local network. Then you have the Trojan horse. The Trojan horse is just another harmful piece of software that looks legitimate. That's the keyword. So it comes in disguise, like deceit. So unlike viruses and worms, Trojan horses do not reproduce by infecting other files. They self-replicate themselves. Okay, so Trojan horse must spread through user interactions such as opening an email, attachment, downloading it, or things like that. Okay, so another kind of threat is what we call the resonance attack. In addition to malicious code attack, it is possible for networks to fall prey of various network attacks. So network attacks can be classified into resonance attack, access attack, and then the denial of service attack. Very, very important. Now, let's look at them one after the other. The access attack exploits known vulnerabilities in authentication services like FTP services and web services to gain entry to web accounts, confidential databases, and other sensitive information. So access attacks can be classified into 4 types. They include password attacks and implemented using brute force, Trojan horse, or some sort of packet sniffers. Then you have trust exploitations, where a threat actor uses unauthorized privileges to gain access to a system, possibly compromising the target. And then you have port redirection, where a threat actor uses a compromised system as a base for attack assigned other targets. Then you have the man in the middle, all right, where you have the threat actor that is poisoned in between legitimate entities. So in order to read or modify the data that passes through those particular parties. That is that. Then we have another type of attack, network attack, called the denial of service. And it's just 2 words, denial of service. So you want to deny access to a particular service. All right. So DOS attack may, take many forms. Ultimately, they prevent unauthorized people from using a service by consuming system resources. So to help prevent DOS attack, it is important to stay up to date with the latest patches. So if you have an operating system, make sure you update it frequently. If you have an antivirus, make sure you update it frequently and things like that. So that is how one way you can prevent. So DDoS attacks are major risk because they interrupt service and cause significant loss of time and money. So these services are relatively simple conduct, even by an unskilled threat actor. Now, we have the senior brother of denial of service, and that one is called distributed denial of service, DDoS. And the distributed denial of service is denial of service, but it comes in a much bigger way. Let's say this is the server, and this server is a mail server. Then this is a PC. This PC accesses this server. A DOS attack is when you deny this PC access to this particular server. How do you do so? You keep the server very busy solving other problems, irrelevant problems that it will not be able to provide the service. So distributed denial service is saying that, okay, how do you keep that server busy? There are different systems that will be infected like zombies. So they'll be infected like zombies. And then at a particular time T, they will all be coordinated to send strategic pressure on that particular server. And that is it. So network attack mitigations. So one way you can mitigate against network attack is when you apply the defense in-depth approach. And what does this mean? All right, you must first secure your devices using using routers, switches, and servers. So most organizations employ a defense in-depth approach. Sometimes they call it layered approach, and it requires a combination of networking devices and services. So you have VPN, you have ASA firewall, you have IPS, you have ESA, you have AAA. So on a network, you have all these services. Somebody wants to gain access to your network, he needs to log in, username and password. That is your AAA. Okay, and then before he even goes there, it requires him to log in with a password, maybe wirelessly. He needs to log in with a password. That's security. After that, he needs to now log in to the account, AAA. After that, he meets a particular firewall to help it to determine whether it will be allowed to pass through or not to pass through, and then VPN and so on and so forth. So if you have a network that you are managing, defense in-depth approach is very good. Another way to mitigate against network attack is keep backups. Make sure you are always having backups of your routers, backup of your switches, backup of your servers, in case your system is attacked, in case your system goes down, you can just run your backup, all right? So it's very, very important. Then another way you can do that, mitigate, is you update and upgrade your operating system. All right, if you're using Windows, make sure you run your updates frequently. If you're using Linux, the same thing. Okay. Okay, we have talked about authentication, where you will now have to use username and passwords. Then you also have the firewall. Firewall is where you create rules that permit and deny. Either permit this kind of traffic or deny this kind of traffic. So a firewall could allow outside users control access to specific services. All right. A network firewall also resides between two or more networks, so to control the traffic between them and help prevent unauthorized access. And we have different types of firewall. We have the packet filtering, which prevents or allows access to IP or MAC address. Then you have what they call the application filtering, that prevents or allow applications from going out based on their ports. Then you have URL filtering, where you will specify certain websites that you want to allow or deny. Then you have a stateful packet inspection, which is incoming packet must be legitimate response to requests from the internal host. So this particular firewall does not permit an outsider to generate a particular kind of traffic. Then another way to prevent is the endpoint security. An endpoint security or host is an individual or computer system or device that acts as a network client. So common endpoints are laptop, desktop, servers, smartphones, and tablets. But securing endpoint devices is one of the most challenging jobs of network administrators because it involves human nature. A company must have well-documented policies in place, and employees must be aware of these particular rules. So, device security. So, Cisco, the security settings are set to the default values when new operating system is installed on a device. In most cases, this level of security is inadequate. So in addition, there are some simple steps that should be taken that apply most operating systems. All right. So one way is the password that we use. Make sure that the password you use is a strong password. Okay, because make sure it has like 10 characters or more. Make sure it has a combination of uppercase, lowercase, maybe numbers and special characters. Make sure it comes in form of sentences instead of just simple words. Okay, instead of simple words. So that is what is basically being advised when it comes to a password. Try to change it as often as possible so that it will prevent people from guessing it. Additional thing on password security is when you are applying password to your routers and your switches. All right. Remember, you can add a service password encryption, or you can create a password for enable mode. You can create a password for anything that you want to do on the router or on the switches. Another way you can do is when you are enabling SSH. SSH is secure shell, and you use it when you want to either access a particular file or resource securely and remotely. So it is possible to configure SSH on your devices, right? So that is the end of our class. We have combined Module 15 and Module 16 because they are very, very short and brief topics. So at this point, I'm going to give chance for questions and answers while we sign in our attendance, right? So, any question? Let me check. If you have a question, you raise your electronic hand, and then I'm going to attend to it. So, like I said, tomorrow on Saturday, we should be taking our last topic, which is Module 17. After which I expect within 1 week, everyone should be able to complete all assessments. All right? We should be able to begin CCNA2 hopefully by February or last week of January. Okay. Any question? Okay, so I don't see any questions, so I believe we have understood our lectures. So please sign your attendance, then we can call it a day.
Yes, I have a question, sir.
All right, so go ahead.
Yes, sir. My question is in regard to the skills assessment.
Yes.
I tried conducting it online, but I trying to load this packet tracer and what have you, and I've been having issues. It's not coming up. I don't know how we are going to go about it.
Yes. You have to have a good network and you have to have the packet tracer application installed on your system. If you have packet tracer installed on your system, you don't have a problem. Okay. Moreover, like I said, after Saturday, I'm going to give you 1 week to complete all assessment. There is a hands-on skill activity I'm going to be giving you guys. So I'll let you guys know that on Saturday. And then I'll let you know when you're supposed to access it and when you're supposed to submit it. So all you just need is good internet and Packet Tracer, the latest edition, and you'll be okay. Thank you.
It's okay, sir.